So hello, I'm Jez, and I'm chair of Kings Heath Pickwick Junior Hockey Club. Thanks for coming. Again, John said he'd give you a discount if you could get him onto a salmon river while at Kings Heath. We've actually got one of our former players is currently playing for GB out in Malaysia. So if you can get me a job near some high quality hockey, you have a discount. That'd be great. So I'm coming at this from a funny angle because this is going to sound very defensive from the start, actually. I'm not here as a JavaScript apologist. I just said, you know, we can't live with it, can't live without it. It's not something anybody really wants to do, but we're all kind of stuck with it to a greater or lesser degree. So when I came up with this title, I thought it was kind of a, you know, gently punning thing because it's on the web. It's like a, you know. But then maybe I should have gone a bit more punchy, a bit more agilely, like a sprint. Oh, hang on, a sprint or a spike. Because there's a lot in this. Okay. When I say ES6, do we know what that means? Okay. Good, because I'll cover that. So there's a lot of stuff that we're going to cover, so it is a bit of a spike, and you probably end up with just a lot of words, but hopefully some will stick. So we're going to have a look at a little bit of the history of JavaScript and why it's changed, how it's changed, why those changes are universally good. It's amazing. They're all good changes. How you can use them, and sort of where it's going. So if JavaScript isn't your thing, it's not many of you to leave, but if JavaScript isn't your thing, you should go. And if you all, I was going to say, if you all left, I could go to Steve's talk, but then they said, but they're videoing it, so I've got to stay here and do it anyway. So if JavaScript isn't your thing, or you're already ES6 up, you should run away now. But otherwise, if JavaScript is your thing, you should stay. So I suspect there's nobody here who's a full-time JavaScript, no other language will cross my keyboard type, right? So it's my contention, my experience, and I'm just sort of widening it out, my contention that most people, JavaScript falls into that kind of other skills category on their CV if they mention it on their CV at all, and they probably don't because they don't want to get given JavaScript jobs, right? So it's a kind of, this is the stuff you have to do. The back-end stuff is interesting, and the front-end stuff, we need a web front-end, so we'll put the JavaScript, and it's always, because it's like the web and that's meant to be, like, my kids can do web pages. We don't really give JavaScript a great deal of consideration. It's a little bit of a toy. And so we don't perhaps pay much attention to it. And the languages that we do use, the Javas and the C# and the C++ and what have you, have all undergone really quite radical changes recently. So they're interesting, right? And we pay attention to them. And in JavaScript, there's lots of languages and frameworks and things constantly coming on, but the language itself has been essentially dead. So we're all kind of, you know, it's just. But that is no longer the case. We had last June 2015, there was a new release of the standard, so ES6, also known as ES2015, is this new release of the Java standard, brings in a whole load of new stuff, and I'm going to cover some of that. But I think, and I don't want to do an exhaustive history, but I think it's useful to look at how we got here, and why JavaScript was really rubbish, and how it's sort of coming right. So this is the web in 1995. Okay, it's a much grayer place than it is today. But we've got all the essential elements of like the modern web here, right? So this is a search engine. This is an online newspaper. I always think this is the Telegraph. And I always thought that was amazing, right? The first British newspaper on the web was the most conservative newspaper, it's the Telegraph. Anyone have a guess at what this slightly out of focus thing is down here? That's eBay, right? And Amazon was still a bookshop. And, you know, Interflora had a website, so you could get your flowers over the web and things. So there were all these, the essential elements of the web that we have now are all here. But any interactivity that you had was you typed in the box, and you press a button, and that went over to the web server, and you got back some HTML, and it might have been HTML just for you, but all the action was happening on the other end. And even that early on, people were starting to see the limitations of that. And so there was a browser called Viola. I don't know if some of you, it was even then it was on the way out actually, but that had a bit of scripting. Microsoft was working on the first release of Internet Explorer, and you can be pretty sure they were grappling the OLE scaffolding in there too. But the kind of king of the jungle at the time was Netscape. And those, do miss those really big square buttons, very, you know. Anyway, so the big player was Netscape, and Netscape were one of the few web companies, novel even now, one of the few web companies you could actually give money to. So they were very popular with companies that like to give money to other companies. So their servers were very widely used, their browsers were very widely used. And in mid-1995, they hired this man to put scripting in the browser. This is Brendan Eich, looking very pleased with himself. There are no pictures of Brendan Eich not looking pleased with himself. It was just... So he was hired in April '95 specifically to put some kind of scripting into the Navigator browser. And I'm not... There's nothing in his history, he was in his mid-30s at the time, there's nothing in his history to suggest that he had any particular skills in that, actually. But he previously worked at Silicon Graphics, so perhaps he just bumped into Jim Clark in the street and got the job. But anyway, so he arrived, full of confidence, and the language he originally intended to embed in Navigator was Scheme. And I think we should just take a moment to think about what the web would be like today if he'd done that. And actually, I think it would have been bad. Because I don't think it would have had the immediate uptake, and then Internet Explorer wouldn't have embedded it, and then we would have had a very fractured. Anyway. So, he was going to put Scheme in, and then somebody at Netscape took him aside and said, no, don't do that. Just come up with something new that looks a bit like this Java thing that's very fashionable, just been launched, very fashionable. So he famously took 10 days to create this new language that was initially called Mocha, and then almost immediately became LiveScript, and it was released in August '95, I think, and then by the end of September was called JavaScript. So it's not a very accelerated development history. If you think about the other languages we use, if we look at a modern example like Go, that had at least 2 years of development before it was released, and that had Rob Pike and Ken Thompson on the team, you know? So 10 days, it's very compressed. And it was all deadline driven, because they knew that Microsoft was making a fuss about their Internet Explorer browser that they were going to release, so they wanted to get this beta out there, and so we had this very accelerated time frame to get it out there. And the initial context for that scripting language was really just to tie together applets and plugins. So they shoehorned the JVM in there, so you had your little dancing Java logo thing, and Shockwave was also around. And so the context for the scripting was basically just kind of wire up buttons and things to the applet. So it had a very limited context, very limited lifetime. It was just ran in the context of the page. You reloaded the page, you know, there's a whole new thing. And even when it was plugged into the servers, it worked in the same way. There was just the page context. There was nothing was memory resident. So it was never really intended to be a proper thing. But, hang on a minute. Yeah, well. So he released this, I got ahead of myself. Anyway, he released this language. This language came out in '95. And, where's everybody gone? No, I've broken my own slides. Oh well. So this language came out in '95, end of '95, and actually was adopted very, very quickly. It went into Internet Explorer in '96, and then it went into a standards process very, very quickly. It was first standardized by the end of 96. There was a second edition in 97. I mean, that standard essentially codified the implementation that there was, but it went very quickly into a standards organization, a wacky standards organization, but went into one anyway. And became the dominant language of the web because it was picked up into IE. IE became more popular than Netscape. Everybody was using it, and it was kind of by accident became this kind of lingua franca. And then there was a third edition of JavaScript, I think in 98, which just added a few more things. But then the progress of the language foundered. It kind of fell apart because by then Netscape and Ike were pulling in one direction and Microsoft was pulling in another direction, and Adobe or Macromedia or whoever had Flash at the time, it might have been Adobe by then, because they built their ActionScript language on JavaScript, were pulling in another, and the standards foundered because it was a much more competitive environment. And so then over the course of the next few years, web innovation happened in other places. Okay, so we had the iframe that came in through, I think, IE, and then the XML, because Microsoft had put that COM scaffolding into IE, the XML HTTP component, and the first use, and using that for the Outlook web app, so the innovation, the web innovation was happening in other places. I think CSS came out of Opera, Hack-on-Lit Opera. So the web innovation was happening in other places, and this language kind of foundered. And then, as browsers got better and our computers got bigger, we began to be able to do larger things with it. So we had, for example, the Outlook web app. Gmail, I think, was launched in 2004, and that was a big deal, right? Because that was widely and publicly available. Google Maps was in 2005, believe it or not. And then we had the second wave of browsers. So Firefox 2 came out around then, and Safari, and Chromium was in 2008. So suddenly, then the web was a live place where we could do and build big things. And so then you see the development of things like libraries like jQuery, which was intended to kind of smooth out the cross-platform differences. And frameworks like Angular and Ember started to appear, and they were all trying to compensate for the deficiencies of this language that everything had accidentally been built on. And this language was essentially dead because the standards process was going nowhere, right? And one of the guys who, this is where I get to this photo. This chap, also looking very pleased with himself, is a splendidly named Jesse James Garrett, right? And he's the man who coined the term Ajax, okay? In an article, I think, on O'Reilly's website. And then after he'd written that article and he described this asynchronous JavaScript and XML Ajax, sort of, once he'd given it that name, then everybody could talk about it, and then there was even more kind of, so, yeah, so, I can't remember myself, yeah, so Doug Crockford's book came out in 2008 as well. It was trying to say, look, this is how we should write JavaScript. So there's a lot of efforts to kind of improve JavaScript without JavaScript actually being changed in itself. And because it was built, we still did all this stuff on a language that, people hate, even now. This is from last year. I'm not quite sure who said this, but Alan quoted it. It's not really a language, and it isn't. Well, it is, obviously it is. But it's a rubbish language because it had that accelerated development time, and because then the wacky behavior that it had was codified as standard behavior. So you've got like really weird scoping and wacky type conversions, and the numbers are IEEE floats, but you can do bitwise operations on them. And functions do like 3 different things. They're like free functions and constructors and methods, and this is dynamically bound, and if you miss out, you know, if you assign an undeclared variable, it just goes into the global namespace. So it's all a mess. I had a slide here on the equality. This is equality rules, and it scrolls off the bottom there, and there are notes. It's just, anyway. You can get a situation where equality is not transitive in JavaScript, right? And that's just... So, now we have ES6, officially ECMAScript 6, as ratified by the good people of the European Computer Manufacturers Association. Look at their membership list. No European companies on there now. It's all, you know. Anyway, so it was ratified on the 17th of June, 2015, and it fixes absolutely none of that. Absolutely none of it, okay? So that means, and this is, you know, all our crappy JavaScript will continue to run, which is actually probably what we want. But the JavaScript we write after that can be less crappy, right? So quite a lot less, actually. So the first, that's how we kind of got there. So the first, are you aware of the kind of the headline things that are in ES6? Does anyone want to just? Futures, promises. Okay, good. Landers. Yeah. That's often where people start. I'm going to start with block scope. I know. Sane block scoping that ordinary humans can understand, right? So if I declare this variable here in this block, it's out of scope here. This was not previously true. This is also an error because it's not in scope until this previously. If this was a var in here, that would have, I'm not going to say it was correct, but it would have done something, right? It's probably not. So same block scoping that normal humans can understand. This is actually, it's revolutionary. It makes a really huge difference. So actually, when I first wrote this, I had a load of examples of how it used to be, but there's that thing about fake news where you have to repeat it in order to refute it. But that actually reinforces the bad thing. So I just thought, let's take it out. So we have this block scope, and you can declare it and then initialize it later. But why would you do that? Yeah.
If the rules of block scoping change, how does all code run?
Okay. Because this is a new keyword.
Oh, right, okay. Yeah.
So when you declare it with let, the new scoping rules apply. If you had a var in here, then the old scoping rules would apply to that variable. So you can mix and match, but you really shouldn't. Okay? But there's more, and you'll like this one, Russell. So when you've got block scoping, then you can also do, as you might expect, shadowing, and it works in a way you'd expect. Probably don't want to do it, but it works as you'd expect, okay? So these are, in JavaScript terms, this is some pretty hot stuff, right? So, you'll like this one, Russell. Okay? So we've got let to introduce a variable. We've also got const, and then this is const binding. It's not, so it's like a Java final or a C# read-only. It's not const, but it's a constant binding. So obviously, you should prefer this over this, and you should forget any other way of declaring variables in JavaScript. Okay? Let the garbage be collected. So, yeah. So this is an error. This is entirely novel and new in JavaScript. So, right. So it sounds like such a stupid thing to say to a room of experienced software developers, but this really makes a difference. It's like you only know what you didn't. It's only in retrospect I can appreciate how rubbish it was before, because you know it's like, so I think also interestingly, if Ike said he wanted to put scheme in and they said no, do something else, right? And so he cooked up this new language and he could have made it kind of scheme-y. Scheme has lexical block scoping, right? With constant bindings. And he invented a whole one. Anyway. So, we can, what is going on with this? Up. There we go. So we can use let where we used var previously. And so if we use it in a for loop like this, then by the time we get to here, I is out of scope, like you'd expect, like you want. That's great, right? And you can also use it in the for in loop. So this for in, for these arrays, it gives you, it loops over the index of the array. So for in gives you the index over the array, and then you can look up the elements of the array, and you can use let there as well. Interestingly, you can also use const here, right? You can use const in this loop. And that looks a bit wacky, but what's going on here is that every time we evaluate the body of the loop, we're creating a new scope. So the loop variable is kind of created afresh for each time we go around the body. So we can bind this, we can declare this as const, we can bind that as const, which for a loop variable you probably want to do, right? Because you probably don't want to mess with it. So we create a new scope. So if for in loops are a thing you do, you might be interested in this new construct for of. And here, instead of giving me the indices, it actually gives me the values of the array. So it loops over the values of the array. And so I don't have to like dereference it, right? And so this is a bit like the range for loop in C++, say. And you're going, well, you know, yeah, so what? But my jQuery library's got a for each, or underscore's got a loop and each thing. But because this is a language construct, you can return values out of it, or you can break out of it, or which Kevin would say don't do, or you could continue, short circuit it with a continue, which Kevin would say not do. But anyway, it's a language construct, so it has, things in here exist within this scope, whereas when you use something like a for each, you've created a closure and it's off to the side. So you've got now more options. And you say, well, yeah, okay, but my for each gives me the index and the value, and I get them both at once. And you go, okay, well, you can have that too. Okay, if I ask array for its entries, I get back a series of index value pairs that I can pick apart here. Now, this little snippet is, I was trying to think, this is like I was trying to think what the appropriate metaphor was. I want to say Rosetta Stone, but it's not the Rosetta Stone, because you can read this and understand it. So it's not, but it's like the thing that breaks open. It's your doorway into the new stuff in ES6. So we've called array entries, which is returning a series of key value pairs, which we're splitting apart, and the first part of that pair is the index, and the second part is the value, so I've got them there, and we've got some block scoping going on, and this is a constant binding, okay? So there's a lot going on here. This entries is not returning an array, okay? It's returning an iterator. And this is another new thing in JavaScript, okay? Whereas before, the for in loop was doing something kind of magical because it knew about arrays. For of operates over things which are iterable, or it operates over iterators. And an array is iterable, and array entries is iterable. So we're not kind of calculating a new array and returning that here. This is on demand. And this is kind of a normal thing. You see it in Java and C#, and you see it in Python or Ruby or whatever. So for of works with any iterable type. And obviously Java doesn't have it has a quite relaxed view of typing. So there isn't like a base class or a formal interface. But so it's kind of more akin to a Python protocol. You familiar with? So if it's got the right methods and the right thing happens. Yeah. So where are we going to go? So any object that has this magical method, square bracket symbol dot iterate square bracket, is iterable. Okay, this is like, again, like Python's underscore underscore iter underscore underscore. So this is like a sort of a magic unpronounceable name. And if it has this method, it is iterable. And so the for of calls the function, and what it needs to return is an object that has a function called next, and that function needs to return another object which has two properties, done and value. And if done is false, it looks at the value, and if done is true, then the iteration is complete. Okay? And you look at that and you go, well, I'm not sure what I'm really gaining here, right? There's a lot of visual noise, and I've had to use, in order to get my loop to work here, I've had to use a kind of a closure over this, and there's quite a lot going on there. And so, we have, there's a lot of housekeeping there, and it all gets a bit curly bracket-tastic. So we have new language support to help this, which is a generator. And generators, as I'm sure you know, are resumable functions. Okay? So this function star is declaring a generator. And as we go around this loop, we return a series of values, we yield up the values, and each time we come back in, we pick up where the yield went off and we go back around the loop again. And then this generator stuff is putting that iterator scaffolding around it for us. So a generator is iterable. So I can drop that in here. So this is my iterable object. It's going to call symbol iterator that returns a generator, a loop on a generator, or we don't need to declare that function part, we just declare it directly. But even better, for like an ad hoc object like this, we don't even need the symbol iterator. We can just invoke the generator directly and loop on that. Okay? And this is really like the Python generators and things like this. It's if you take out the colons and put in the curly brackets and change def for function star, then they work. So what you do in the body of the generator is whatever you like. You can have multiple yields. If you return out, then if you fall off the end or you return, then the iteration ends. You can do whatever you like in here. Okay. You can, if you're on the server side, you could be looping over a database cursor or any of that stuff. You could be walking your DOM tree on the client side. You could be parsing your JSON, all that thing. You can, you can nest these as well. So if you have a generator in a generator, if you're familiar with Python's yield from, that kind of effectively loops over another generator, there's a yield star which does the same. So you can have generators upon generators. And so this is actually some pretty cool stuff. I gave a shorter version of this talk about a year ago, and I kind of, in the middle of this, kind of casually said, yeah, then you could write like a Java Stream style library or a link style library. And I thought, well, I've got a bit more time. So I did that here. And so I'll show you the code in a minute if it's even feeling super keen. So Lodash is a library of functional programming style. What's the word I'm looking for? Functions, right? So map and filter and things, but they all operate on arrays. So you call map on an array and you get an array, and you call filter on an array and you get an array. So when you chain them together, it's like eagerly evaluated. You get an array and an array and an array and so on. And here, if I throw a little wrapper around this, then I can set up my filter. So I'm creating a generator in here, and then a generator in here, and then nothing happens. So this is all then like setting it up, and then nothing happens until you call that one, and you pull the value through, just like JavaStream, or just like a C# link method, or something like that. So, and in fact, this is an example straight out of Rob Smallshire's Python talk. So this is a Lucas sequence, because 60 North don't do Fibonacci, right? It's the same, but with different start values. So with the generators, you can operate over an infinite sequence, right? And so this is an infinite sequence, but here I'm able to apply the same, by popping these generators around it, I'm able to filter it, and sorry, I've exceeded the Jagger threshold here, but you can set this stuff up, and this can be arbitrarily, complex, and I think, yeah, so I did let's show you. So this, if I've got some kind of iterable, like a generator and a predicate, I can just throw a generator around it and loop on that, or I can map that, so you can compose these things together really easily. In fact, if I go whiz down to the bottom there, that's all this stuff here is doing, is just building up this sequence of generators. Like if you were in Phil Nash's talk this morning, when he had his pipe operator, and he was saying, I'm going to take this, his optional, and wrap it in an optional, it's kind of all inside out, isn't it? So if you flip it this way, this is doing the same thing. So you get the kind of that fluent style API, and you wrap all these generators up, and then you pull out the results you need. So what I had then intended to do, having shown this, was come back, was just say as a kind of toss it out comment, say, and you can do coroutines with this, and then not just sort of leave that hanging. But then again, Rob Smallshire did that in his Python talk, so I crossed out his colons and wrote the thing, and came and did like coroutines. It was brilliant. So we've got, again, the Lucas sequence, and a very time-consuming way of checking for prime numbers, okay? And JavaScript doesn't have a range like a Python range, so I wrote one here in this generator. And so if we give our iterable object and our time-consuming predicate, we can just march over this forever and print out anything we find, right? And here's another little generator, this one here, repetitive message, which every so often is going to print a message. So, and there's my sleep. I'm going to say, yield here is returning nothing. It's a bare yield. It's just saying interrupt my coroutine at this point and then pick up. So this is going to sleep. And you can write a trivial round-robin scheduler. I've got a little array of tasks. Take the first task off. I'm explicitly invoking that next method here, rather than doing it in a for of loop. This is me explicitly invoking it. And I'm saying, well, if it's done, then it's finished, take it out the loop. Otherwise, pop it back on the other end and go round. And you get, I don't know if you were in Rob's talk, but then you get, I can't remember the command, that. Then, here we go. These are the first prime numbers in my Lucas sequence. And I live a less jet-set lifestyle than Rob. So he gets, he gets asked to look for his baggage on the carousel, but anyway. So here we are, and this is taking progressively longer and longer. Got another timeout task there. And then we've actually got a clean shutdown, because one of the things that we also have in the generators, which I don't think we have in Python, is if instead of calling next you call return, the generator is cleanly closed off and it all unwraps all the way up. So the code I just showed on the slide is not quite the code that I was running. I've got another task which, if it finishes, shuts down everything else by calling return on it. So let's just lodge that there. You probably won't need it very often, but it's there. So that's quite exciting. Let's go back to, oh, where are we going? Where's the thing? There we are. Come on, there we are. So, you've seen very briefly this destructuring where I'm getting multiple return values and then I'm picking them apart here. And this is a key value pair, or index value pair rather. If I have like an arbitrary object here, like this is an array of, playing cards. I've got 3 playing cards in my array. That's kind of ad hoc objects. Then I can split those apart in kind of one action. Get the first, second, and third out. If I just want the first one, then I can do that. Or if I just want the third one, I can do this. So these are kind of discard, discard, take the third one. And I can also, this is going to end up bound to this, and this has 2 properties, and I can pick these apart like with this curly bracket. So it matches the syntax. So an array destructure has a square bracket because arrays have square brackets. An object destructure has curly brackets. And in fact here, if I wanted my suit and my card, I didn't really want to call them S and C, I wanted to call them suit and card. There's like a little shorthand syntax for that as well. It just plucks them out directly by mapping the name that you want to bind to the name of the property, which seems a little bit magical, but there we are. And you can arbitrarily nest them. So you can take the first card and immediately pick them apart, and then again you've reduced your scope. Stay with me, Seb. Stay with me. And you can see, if you had like a JSON object you were fetching and there was only a part of it you were interested in, you could see how this would maybe allow you to reach down without, introducing unnecessary intermediates and keeping your scope, again, unpolluted and nice and clean. So you can also, with the destructuring, you can call, it doesn't have to be just the sort of user-defined properties. You can call any property. So an array has a length, and you can pull, that's the wrong sorting bracket, sorry. But you can pull out the system properties as well. But array destructuring is not just for arrays. It's for iterables. So you can pull apart, you can actually plug any iterable in here. String is an iterable. So if I do this, then W, X, Y, and Z are going to get bound to, fuck, where's it gone? Yeah, no. Oh well, they're going to get bound to, they're going to get bound to the first 4 of these, A, B, C, D. But I can put any kind of iterable in here, anything at all, and the array destructure will just pull off as many values as it needs. If there aren't enough, then these are undefined. So if, and that's great if I know the exact shape of the thing that I want to destructure, right? But what if I want to take some of it and then keep the rest around for later? Then we can do this. So this is called the REST operator, which is an unfortunate term in web development, a web development environment, right? But this is the REST operator. So the first, for this string case, the first value here is going to get bound to head, and if we had any others in here, they would bind in the same way. And then this REST operator exhausts the iterator. This does actually realize an array, but it will exhaust the iterator and gather up everything else so that you can then carry it around for you. You call them head and tail, call them whatever you like. But so you can gather up the remaining elements of the iterable into an array. So in this case, this will end up, head will be A, and then we'll have this array of the remaining elements in the sequence. We can also provide default values for the things that we're destructuring. So if this response object didn't have a message property, message would be no error message available. Okay? But this can be any JavaScript expression. It doesn't have to be a literal. It can be any JavaScript expression. It could be another variable. It could be a function call. It could be anything. And again, in Phil's talk this morning, he was talking about having to wrap things in lambdas to delay the execution if your default object if your default value is expensive, say. Here, this is done for you. This is not evaluated unless it's needed. So this can be arbitrarily complex, or could be, oh my God, the whole thing's falling to pieces, you know, shut the system down, and it won't be evaluated unless it's needed, which is quite cool, I think. So we've got, destructuring gives us new ways to manipulate data that we just didn't have before. So let's have a look at, so the destructuring is sort of us taking things out of objects and iterables. And when we pass parameters, we're putting them into a function. And we can do similar things here. So we can now provide default values. And again, this is not evaluated unless needed. This, of course, is a real example because JavaScript runs everywhere, right? There's not a device in the world that you can't run JavaScript on. So I think it's entirely plausible, given some of those user interfaces, that, you know, the enterprise is running JavaScript. So let's do that. So yeah, so if we do this, max is not called, and if we do that, then it is. And this is, again, this is one of those stupid things which is really a major advance for JavaScript, because previously, if you wanted to do a default value, you were within the body of the function, checking for undefined, and then providing your max. But here, this is explicit. You can also, because this can be a function or another variable or whatever, you can this could be like a config thing. You can parameterize your defaults from above because they're runtime evaluated. You can actually parameterize them from above in a way that you can't. You certainly couldn't in JavaScript previously, but you couldn't in, I don't know, C++ or Java or something. So that's really quite cool. This is our REST operator again, and now we have a sensible way in Java to do variadic functions. So if I pass in, you know, if I pass, what have I got here? So if I just pass in one parameter here, that's going to get bound here. In this case, my string is going to get bound to pattern, and then as many other arguments as I have is going to get gathered up into an array and popped in here. So we don't have to check that magical arguments parameter. And was anyone in Andy Balam's talk on implementing a language? It's really nice. And he took you through, and he wrote this really small language. It took him about 10 days, turns out. And he talks about, you know, how you implement, how you lex it, and how you implement, you build your AST, and how you then walk your AST. And he showed us a little implementation of block scoping, right? And it was so easy and obvious that you do wonder what's going on. And the magical arguments thing that JavaScript has is another just super strange thing because it's not like any other object in the JavaScript runtime. So now we never have to think about it again because the REST operator is gathering those things up, and we've got a sensible thing that we can, first of all, we can indicate that we're expecting variable number of arguments, and then we've got a sensible way to deal with it. So these are like, this is almost bringing us into, I don't know, the late 70s? Or is it earlier, Russell? You. Okay. We can also then combine destructuring and defaults and parameter binding all in one go to kind of simulate named parameters, right? So I'm expecting this, waggle my robot arm, I'm expecting an object which I'm going to destructure into 3 parameters, extension, and I'm going to give that a default. I'm going to give these, obviously these are defaults within this destructuring, but also that I'm going to provide a default value for my argument things, right? So then I can pass as many or as little as I like. So if I do this, none of the defaults are invoked. If I do this, then these are picked up. And if I do this, well, that's all empty, so they'll all get picked up. And here, that default is in play, and that doesn't have any, so that's, but that's quite, maybe not quite cool, but it's quite good fun, right? And again, it gives us a way to express things that we previously couldn't. Right. So this is the final thing on parameters. This is our 3 dots again. This is no longer the rest operator. This is a spread operator. What is it? You've got a nasty taste in your mouth, Russell, is it?
So the difference between the semantics then is a preceding comma and not.
But this is a call, not a declaration. So numbers is an array, and what this spread is doing is instead of passing the array, it's opening out the array and passing them as 4 separate arguments. Yeah. So these two are, this effectively becomes this. And this again, these rest and spread, they operate, whenever I say array, I mean iterable, right? So this will operate with any iterable. So obviously you've got to be careful, put a Lucas sequence in there, will blow up. But any iterable, any generator, and it pulls it apart. So that's quite good as well, actually, quite useful. So it seems kind of silly that we spent a lot of time talking about like block scope and iterators and things, but I think they all hang together, right? So they're all of a piece and they're all consistent. And consistency and things that make sense and that are logically hang together. Because it's not just syntactic sugar, this stuff. This is new stuff in JavaScript. But the consistency of it and the fact they kind of fit together in a logical way, these are novel in JavaScript, right? And hopefully they are the core of like a better, more consistent JavaScript, right? And it's had thought put in by actual people who spend time thinking about things. And so it's consistent. I mean, it's just crazy. What times we live in. So let's do that one. So we should have a look at arrow functions. Again, because of the kind of history of JavaScript, terms like closure and lambda and function expressions, everybody means something slightly different by them. And so I think in the JavaScript context, when we're talking about these new arrow functions, we should call them arrow functions because they do operate in a different way. They're not just sugar. There's something new going on here. It's not immediately apparent in this case, but there is something new going on here. So this is going to work exactly as you expect. I've got an array. I want to map a function across an array. That's going to pass in each element of the array in turn. Here I'm just evaluating an expression. This is kind of the minimal form. Because I've got one parameter, I don't need to put any brackets around it. Because this is an expression, I don't need to put return or curly brackets or anything. This is And this is probably the form that we generally will use. And this will work exactly as you expect. Okay? Now, yeah, so here's an expression body. You know, this is obviously not returning value, it's an expression body, so it's slightly more. Right, so functions in JavaScript, I said before, they do like triple duty, and they're kind of bad. They're bad, like non-method functions, because of this parameter. And we, you know, if you come from Java or you come from C++ or something, or C#, this is, you can rely on it, right? This in JavaScript is dynamically bound, and it will change according to the object that invokes the function. So you can write a free function that refers to this, and the this will change underneath it, right? So it's Doug Crockford, or it's someone on the Yahoo UI teams. When a function is called with a function invocation pattern, so like it's a function, its this is not bound to the outer function's this as we would hope, and even now you're kind of already lost, right? But is instead bound to the global object, which is horrible. ES5 strict mode binds the inner function's this to undefined, which is much less wrong, but still wrong, right? And so we have, as I hate to use the phrase JavaScript practitioners, but as JavaScript practitioners, as a community, a global community of JavaScript programmers, we've come up with various ways around that. And so we do things like, so I've got a little, here's my multiplier class, and it's got a multiply array. I give it a factor, so it's a multiplier. And I'm going to pass in an array that I want to map my multiplier across. So I write, this is, you know, you used to see this a lot. You'd write your little anonymous, your function here, and we'd assign, at the point where we get to here, this is this. So we'd assign this to that, so that we would capture that, which is a non-magical parameter, here, because otherwise, if that said this in here, this would be that. That's it. So, right? So that was one way we did it. It was awful. Some APIs allowed you to pass into this that you wanted to be used when the thing you were passing in was invoked. So you might have something like this, and that. So you write your function with this, and then you pass this in, and that's crazy as well, right? Or we would explicitly bind this to this. This is like currying this function. This is like a currying operation, right? But this is not a parameter to this function, so it's because it's, you know, so that's weird. Or, and I accept this probably isn't what you do in this case, or we do something like this, which is define a function that returns a function and then immediately invoke the function to get the function that we want, because then this is captured in that scope, right? Now we don't have to, you know what I said before about not giving the counterexamples? Now you don't have to do that, because with your arrow function, this is the right thing. This is whatever it is in the lexical scope where you write that arrow function and you cannot change it. Doesn't matter how you try and mess it around. I'm very aware of the microphone because I nearly said a naughty word then. It doesn't matter how you try and mess it around. Even if you try and rebind it, it will not change, right? So this is fantastic, because it means then we can write nice, easy to read stuff that then works as we would wish it to work, right? It's a revelation. So it's determined by the surrounding scope. Can't be changed by accident or on purpose. You just can't do it. So just for completeness, excuse me, look at the syntax here. So if you've got no parameters, if you've got like an anonymous, parameterless arrow function, you do need the brackets. If you've got one parameter, the argument, the brackets are optional. If you've got multiple parameters that go into your arrow function, then you do need the brackets. And you can combine this with destructuring and the defaults and all that other stuff that I showed you with parameters before, okay? and then the body of them. The only weirdness here is that you can't have a line break between the parameter declaration and your arrow. That's the only weird thing, right? I think so. If Python's allowed the colon, which is a wart, right, then I think we can, given all the other weird stuff that we put up with in JavaScript, right, not putting a line break in there is just a pretty small beer, right? But that's the one little weird thing. Sorry? It's unnecessary. Because it's white space. It's the moat in the eye, you know, we don't, anyway. So, and the body of the arrow function, it can be block structured, but if it's an expression that's just returning, you know, then if it's just an expression, then we don't need any of this, okay? So, and I think most of the time, we're probably going to be writing things which is pretty much this, right? So it's great. So they're not sugar. They are, again, a new and useful thing. Right. Oh. So, Seb, yes. You said arrow functions. Mm-hmm. What's my title? You did? Well, you said lambdas, but it's what I knew what you said. That's what I meant. And promises. So, excuse me. So, both Rob Smallshire and Phil this morning talked about callback hell, which as JavaScript developers we are, of course, all very familiar with. So I've got a function here, and I'm calling something to get my user, and when the user arrives, I'm passing in even with my arrow function here, this is pretty, you know, heavy going. So I'm passing in a function here, my callback function here, that it's a happy case, or my sad case here. So when I get my user, then I need to go and get something else, and I do it again, and then maybe I'll do something else, and then it goes again, it goes again. And the kind of, you know, our Jagger limit is approaching over here. The flow of control is not immediately obvious. We've got duplication in the error handling. But this again, and before we had the arrow functions, we often had a lot of immediately invoked things to get the right this at the right time, and you had this sort of combinatorial explosion of brackets of various types, okay? So, and particularly on the server side, we do it a lot on the client side with JavaScript, but if you're writing anything on the server side, particularly Node, the whole of Node is eventing. It's all callback driven. And again, you get very deeply into this quite quickly. So this is the kind of situation that promises help with, because instead of then passing the callback, the promise kind of looks after itself, and when it completes, it will invoke something on itself. So if we have a kind of a promisey version of our asynchronous function, internally we create this promise and this is a little bit messy, you know, there's a little bit boilerplate here, new promise, and the promise takes an arrow function or an anonymous function that takes two parameters, and it does the thing, and this is passing in kind of like, almost like signal handlers for the promise, right? So if it's successful, if it's happy and it settles, that's the phrase they've used in JavaScript. I don't know if that's, I would say resolved, but they say settled. If it's settled in a happy case, you call resolve, and whatever argument you give here kind of propagates out. Or if it's gone wrong, it's settled with a reject. And sort of externally, here's our async function, and when resolve is called, this parameter is used to invoke the function we pass to then, and if it fails, then the error value is used to invoke the function we pass to catch. Okay? So a promise blocks, essentially, until it's settled, and when it's settled, it will either call then or catch. And you can see, just if you squint a little bit, you can see how that might help in our previous example. But there's more going on, because whatever comes out of this then you can chain the then calls. So if the result of this is another promise, then we sit on that promise, and when that resolves, we call this, and so on and so on and so on. If this is not a promise, it gets wrapped in a promise. So that we can chain our thens, and if any one of them goes wrong, then we kind of immediately fall through to the catch. So if we had a promisey version of the thing I showed you before, we could maybe write something like this. So I want to get my user, and then I want to get my notebook, and then I want to do the other thing, and then I want to send the result back. And if any one of these fails, then I invoke my error handling. Now there's still a bit of, there's still a bit of this, but that's much, the flow of this is immediately obvious in a way that the other one wasn't. And visually it is much better, and I think the comprehension overhead is much lower.
Could I just make a pass on that?
Of course.
Kotlin and Ruby having the it parameter for single parameter is actually a neat trick.
Yes.
That sort of thing will be even more useful.
Yes, it would. Yeah. So these are going to get implemented in series. They're going to get invoked one after the other in series. If you actually want to fire them off in parallel, there's a thing called promise all, which will take a number of promises and sit on all of them, and then give you all the results back in an array. And if any one of these fails, it will immediately bail to the bottom here.
Is there a promise end, which just takes the first return?
Oh, actually, no, I don't think there is. I don't think there is. So the catch is always optional, by the way. If you don't have a catch on the end, then if there is a failure here, it will sort of propagate off the bottom and be raised as an exception. Okay? And similarly, I said that then will always wrap whatever this is in a promise. So if you don't return a promise, and you have a normal kind of function in here, if that throws an exception, that will be converted into the reject. Or if you return a value, that will be converted into the resolve. So here's a little example of converting a callback-based API into a promise. So we've got the XML HTTP request, which has an onload property that you need to set with a function that is called when the document is loaded. This is fetching a web page. And you'll note this has, because of the way this is specified, I can't use an arrow function here because I need this to be whatever it is. It's mental, right? So I'm going to create my request. I'm setting up my onload function. And if it's successful, I'm going to resolve my promise. So when this is executing, even though it's going to go down here and go to open and then send, even though it drops off the bottom here, the promise is not resolved. It doesn't, you fall off the bottom here, and nothing's going to happen until I get my callback function into here and resolve it, which means if this is in a library hidden away somewhere, I can do this, right? And that looks like something that makes sense. I can read this. So, This here is another new thing, string interpolation. Oh, you've missed the smallshare part of the talk, Rob. Oh. So, promises are cool. They're going to be good. My content, we can travel back in time, that's right. My hope is, JavaScript, as we know, has a very rich library infrastructure, right? But they're all very maximalist because we didn't have language support for any of this stuff. A lot of them have their own kind of iteration protocol, or their own kind of promise, or their own kind of whatever it is. So my hope is that now we have like standard versions of this, we'll all migrate to that, but also that the iterator will become the kind of lingua franca of the libraries. so that you will get, you know, you can use something from over here and it'll give you back an iterator which you can drop in over here. I hope that would be the case. Given the history, probably not, but anyway. So, there's more, and we'll sprint through it very quickly. This is very boring, but there are some more things on array, but you don't want to use those. You want to use that thing I showed you earlier that I wrote. Some more object methods. So, these do what you expect. So object keys gives you an iterator over the keys in the object, but only the keys in that object, so you don't have to do that crazy is own property of. That's not landing with you guys, is it? But this saves us from another bit of kind of JavaScript pain. Values obviously loops over the values, and entries gives you that key value pair I was showing. Sorry? Yeah, I didn't realise. I've only gone about 5 talks this year, right? Because every time I sat in a talk, I thought, oh, now I need to go and revise my notes. So when I sat in Rob's talk, I was going, oh, that's just like this. But I mean, it's not a bad thing, right? Yeah. So, you know, this is going to do what you expect. So the keys is going to go, you know, number, name, city. In the past, with the way we used to kind of iterate over keys, you could not do this. You had to have a whole load of if guards in there because it was going to go down the prototype chain. These don't go down the prototype chain. We also have template literals that work in exactly the way you expect from your choice of language, from Groovy or from Python. So it's this little backtick that's the magical thing here. It's not all strings, it's just the ones with the magical backticks rather than single quotes, double quotes. This in here can be any JavaScript expression. So it can be, again, arbitrarily complex, but you use your own skill and judgment in. There's also, I don't have an example of this, but there's also, this is a template literal. There's also a thing called a tagged template, which means you can write your own processor for strings of this type. No, but which means that the language will do the parsing for you and the evaluation, and then you just have to, you can work through it. So it's done the hard part. So if you're writing a DSL, a little DSL, it's done the hard part of the parsing for you, and then you can just step through the tokens, okay? It's probably not a wide application, which is why I didn't do an example of it. Also, I couldn't think of a good one. But you can, that is there if you need it. People don't really write classes in Java anymore. I think we did, like at the start, 20 years ago, we're very keen on them. But we don't so much because it's a massive pain. It's actually, nobody can remember how to do it. You have to set up the prototypes and all the rest of it. But now we have this that does what you'd expect, right? So I'm going to define a class. This is extending a thing, doesn't have to extend a thing. This is my constructor, you can tell, because it says constructor. Invoke my base class. Here's a member function. Here's an accessor. Here's a static member function, and this works exactly as you expect. And this is entirely sugar, right? So the result, this is exactly as if you'd done it longhand, but it's actually quite an easy, nice, easy way to do it. So I think we will start to write classes again. Every JavaScript runtime environment worth its salt has a module syntax. There's now a standard module syntax, which is different from all the others, and it's different in an interesting way, actually. It's not the syntax so much as the behavior. So CommonJS and what's it called, AMD, they are effectively dynamically evaled into the runtime environment. And the standard modules are statically evaluated, right? So again, it's avoiding the namespace, the scope pollution that you might otherwise be able to do, I think. Which is why, actually I'm showing you this, but I'm not aware of anywhere where this is yet implemented because it's a more difficult feature. And then Even more. So there's more library methods on various things. There are binary and octal numeric literals. Just what we need. Some more stuff on regular expressions. This is, again, one of those things that you would probably never do, but it's consistent. So the built-in classes, you can now subclass. You probably wouldn't want to, but it's making the object model more consistent, okay? Unicode support, so like Austin had his little tree, you can now name your variables tree, emoji. There's tail calls, proper like tail calls, so maybe Ike missed a trick again, they're making it right with the tail call recursion. There's some stuff to do with proxies and reflection, so runtime proxying and reflection, which I think is kind of like you can do in Java and things. It's probably a bit specialist, that's why it's down the bottom of the list. These are obviously in order of interest, you know. And then if you've got a syntax for modules, then you might need to mess with where you get them from. This exists. There's probably only 3 people in the world need to know it, you know. So, right. Oh yeah. Module like this. Oh, that one. Right. So, this is all very well. Yes. You could, if you were feeling keen, you could rely on browser support. Let's have a little look. Oh, there it is. This is a compatibility table. You can see, look, tail calls, not good, quite tricky. These are various browsers. So actually, look, the browser support is not bad. This is IE11. There we go. That's Edge. That's pretty good. Firefox, pretty good. What's that one? Chromium? Even Safari, actually. Obviously, the guys at Apple have started working again, because this time last year, this was absolutely shocking. So browser support is pretty good, but of course we can't rely on it. If we go sideways off the end here to the mobile browsers, that's just a disaster area, right? It's just hopeless. So let's go back over there. So anyway, the answer, as I'm sure many of you have guessed, is transpilation, of course, because that's what everybody does anyway. And that's, there's been a lot of effort expended by a lot of people in coming up with other languages to try and work around these various things, and they're all transpiling down to Java. And actually, for nearly all of the things we've seen today, you can transpile them down to Java 5, which is sort of universally supported. And the fact that we never did is because it's really long-winded and tedious. But if we let the transpilers do it for us, then, because I think pretty much everyone has got some kind of minification or uglification or whatever you want to call it stage, and you might even be using a transpiler now without even knowing it, right? Because it's probably, if you're using Ember, for example, it's in your toolchain anyway. So the cross-compiler of choice is a thing called Babel. And this is their Australian outfit, I think, so it might be Babel. Babel? And it's very good. And it tracks the standards extremely well. They're very good about finalizing things extremely quickly, and if things get dropped out of getting slightly ahead of myself, but if things get dropped out of the standards process, they take them out. So they don't leave stuff lying around. They're extremely good. There was, a Google project called Tracer that seems to have, it was very good, but that seems to have, stopped. Maybe that'll pick up again. You could also use something like TypeScript. Because TypeScript is a strict superset of ES6, and it gives you other things, the type annotations. So there's a class of errors that you don't get with that. But, I'll come to the button in a minute. So you can use it today, and sort of transpiling through Babel or whatever. If you're on Node, if you're on the server side, you can do it natively with Node. It's great, just works. You don't have to do any, you used to have to kind of give it flags to turn stuff on, and now it's native. So, and you should, if you're doing JavaScript, you should be, ES6 is like a whole new language with easy to use concepts like block scoping. You should use it, right? Don't not do this stuff because it's just, you're just making work for yourself. Going forward, so we had this huge gap when ES4, the fourth edition of the standard, just wasn't happening and eventually was abandoned. And the fifth edition was basically just, I think, crossing out Brendan Eich's name and writing in somebody else's name as the editor, right? So this long period where there was no change. And so the ES5, JavaScript 5, I think 2009, and ES6, or ES 2015, it was only 2015, so that was 6 years. So you think, well, that's great, we've had all this new stuff, 6 years to get it all sorted? No. They are now, and this is a kind of, I think, perhaps, I don't know, quite an aggressive model of language development. They are yearly releases. In June every year, there's a new version. So this is why I've kind of gone back and forth in my headings between ES6 and ES2016. They're not the same. I think ES6 is like a kind of, it's what people use when they mean modern JavaScript, right? But we should perhaps be a little bit more precise. So there was ES2015 with all that stuff I showed you. Then ES2016, which had two things. It had one new method on array and the exponentiation operator. Heady stuff. But the point is, the release happened, and the process that they'd established to work new features into the standard went as they said it would do. So the stuff that was ready was in, and the stuff that wasn't ready just carried on over. So that was ES2016 June last year. So June is coming up. It's just over a month away. And so ES2017 is almost here. And I've actually, so it's 2016, I should do my slides, there we go, 2017 is almost here. And I've actually already shown you some of it. So when I said that object values and object keys, object values and object entries, that was part of ES17. It's not the important part. The big part that's going to be kind of cool is async and await, which works. Here we are, we're back in the small part of the talk. This works exactly in the way that you described the Python ones working. So if you go back and watch Rob's talk after this. So anyway, so if you're using async and await like you do in Python or on the .NET platform, or I think this is how it's also going to work in the C++ in the future, you have an async, you declare a function to be asynchronous, and await will sit on a promise. So this is returning a promise, and it will sit on the promise, and when the promise resolves, you get the value back. And if the promise is rejected, it raises an exception. So then we're back to an even more linear sort of control flow, and the scope is nicer because let's say if I need a user and notebook together, I can just use them now, and I don't have to. You maybe would have to do some slight unpleasantness to pass it down. So this is nicer and easier, and you did something cool with your coroutines, and I think if I'd had a bit more time, I could have got that going as well, but I wasn't paying attention because I was really writing notes for the earlier bit of the coroutines, so I missed that part. But yes, so async and await is going to make working with those promises even easier. Yes. So, and again, as with many other languages, await is only a valid keyword inside an async. Then if you await on the thing that's not a promise, it converts it into a promise for you and does what you'd expect. That's great. So yes, so that's already here. 2018 is in train, and nobody really knows what's in it yet, but there are some really... When you think about JavaScript, you don't think about like atomics and shared memory. There's a proposal for that. Simmed extensions. you know. There's a list on basically a list of issues on GitHub, and they've got a number next to them from 0, which is somebody just reckons, through to 3, which is really likely to go in, and you can just watch them happening. And that compatibility chart I showed you, they've got another tab on that with all the proposals and the state of them and how they're supported. So it's a very visible process, right? So, and then clearly, obviously then, 2019 is coming. So I think you should, you know, this is now, there are exciting, for some value of exciting, there are exciting things going on in JavaScript, and it has been profoundly changed. It's almost like a new language. It's been profoundly changed by what's happened recently. It is continuing to change in ways which are interesting. And so you should, if you're working in JavaScript, you should get it. You should get this transpilation phase into your tool chain, and then you should turn it up as high as it will go. Because it will make our lives easier, which will make our programs better, and then we'll be happier and more relaxed programmers. And I think that's it. Thank you.